So up to this point in the course, we've been using integrals primarily to find net area. And what we did was we took the height of whatever function we were dealing with, and we integrated that output, that y value, from some starting position to some end position. And by integrating that output, by adding up, by summing up all those vertical slices of the region whose area we were trying to find, we got the total area of the region. So now we're going to go up in dimension, one more, and we're going to find 3D volumes of three-dimensional regions. And the way that we're going to go about it is we're going to slice that three-dimensional volume into two-dimensional subsections. And we are going to integrate, we are going to add up the sum total of the areas of all of those two-dimensional slices, the same way that we added up the heights of all those one-dimensional slices. And here is a quintessential example. We have got a four-sided pyramid. The base is square, and it's being constructed so that at the bottom, each side of the pyramid has a length of 10 units. The pyramid is 20 units tall. What is the pyramid's volume? Now, whenever you're dealing with a question of this nature, it can be very helpful to get a little sketch going. Actually, I'm going to move that down just a little bit. Here's our square base for the pyramid. And here you don't have to be like a good artist or anything. Goodness knows I am not. Just a sketch to get your mentality right. Here is a pyramid with a square base, and let's indicate that the side length on the base is 10, and that the height of the pyramid is 20 units tall. Now let's imagine taking our bread knife and going into this pyramid and slicing a piece out of this pyramid with our bread knife. Let's see if we can find an expression for the area of this slice. So, to begin with, let's figure out where, quote unquote, this slice is located. So let us call the bottom of this pyramid, let's say that's at the location x equals 0. And the top of this pyramid, let's say that that's the location x equals 20 units above that. And someone has given us just some arbitrary x value. Somewhere between x equals 0, the bottom of the pyramid, and x equals 20, the top of the pyramid. Let's try and calculate a of x, the area of this little slice, at the arbitrary x value, x. Whatever number this is, let's try and find a formula for the area of this cross section. Now notice that the cross section cut out by this bread knife has the shape of a square. Since the shape is square, I can find the area just by squaring the side length. So I will say a of x is equal to s of x squared, where I will use s of x to represent the side length of this slice at this arbitrary height of x that someone has chosen. So let's see if we can find an expression for that. The side length of this triangle decreases from from a value of 10 when x is 0 and we're at the bottom of the pyramid, to when we're at the top of the pyramid, the side length is now 0 because there's no square that is going to fit at the very tip top of this pyramid. So let's find the equation of the line, the linear function, which satisfies s of 0 is equal to 10 and s of 20 is equal to 0. Now the change in y value, negative 10, over the change in x value, 20, gives us a slope of negative 1/2. And the initial value of 10 gives us a y-intercept of 10. So the area of this slice at some arbitrary height x can be found by taking 1/2 x plus 10 quantity squared, or put another way, 1/4 x squared plus minus 10x plus 100, to simplify that. Now, having found a formula that gives us the area of a slice at any x value, we can integrate the area function from the bottom of the pyramid to the top. We can integrate 1/4 x squared minus 10x plus 100 from 0 to 20. First, by taking an antiderivative, 1/12x cubed minus 5x squared plus 100x, and then evaluating that antiderivative from 0 to 20, giving us a final answer of 1/12 20 cubed minus 5 20 squared plus 120, and plugging in 0 will make all three terms 0 and will contribute nothing to the outcome at all. So this would be the final answer. So let me summarize the basic process. To find the volume of some three-dimensional object, first, I strongly recommend to start by drawing that three-dimensional object and to impose some coordinates on your picture. For example, we have decided that x equals 0 would correspond to the bottom of the pyramid and x equals 20 would correspond to the top. Then slice, as if cutting a loaf of bread, slice that three-dimensional figure into a bunch of two-dimensional slices. Pick one arbitrary slice and try and figure out its area. Then integrate the area function from the beginning of your three-dimensional figure to the end of the three-dimensional figure. And this is the beginning of the process of finding volumes by the method of slicing method.